All right, our friends here have more to say. So we touched on this. So if A is A transpose, that's symmetric. So this is A is symmetric. It's our word. A is symmetric. And A has n healthy pivots, so that means they're non-zero. Right? We don't have any disappearing ones. There are different ways to say this. Then the LDU decomposition, and yes, it could be P times A, but let's talk about this to start with. Actually, it turns out to be like this. And so we had an example in class, and I'll write that down, but it's LD, the pivot matrix in here, L transpose. So U is actually the same as L transpose. So that's pretty cool. Let's see, so basic check is, does this factorization work? So A transpose is equal to LD, L transpose, transpose. And we have our rule, we're going to swap everything, swap the order, reverse the order. So we get this guy, it's L transpose, transpose, D transpose, and then L transpose. Goes to here, goes to here. Transpose, transpose, back to where we were. So L and D transpose, it's diagonal matrix, so it's just D, L transpose. This is the same as what we started with here, A. So A transpose equals stuff equals A. Good, so that's cool. And we had an example that looked like this, and I'll just write it down. Minus 2, 4, minus 6. I know, you can twiddle your thumbs while I do this. 65, pretty crazy town banana pants looking thing. This is A, little example, and breaks out like this. So, important things. The L matrix is always square. It's a combining matrix. It always has the structure of the upper triangular, the upper part of an identity matrix. And then we have minus 2, 3, 4 here. Right, these are this is L21, usual stuff, L31, L32, and then the pivots, in this case, minus 2, 5, 3, it's a diagonal matrix, zeros everywhere else. And then the transpose of this business, so zeros are down here, and minus 2, 3, and 4. Cool, so there it is, L, D, and L transpose, which equals U. So that's pretty groovy. Now, of course, just to remind you, if we're starting with A and we want to get to this, suffering, much suffering, right? Always. This is hard work. We tell a computer to do it, or we do little ones by ourselves, but this is simple this way, right? Once you've unpacked A into its pieces, it's easy to build A back up again. But all of this structure is hidden. Okay, so that's super groovy. All right, cool. Okay, we okay, buddy? Okay, all right.